In this video, we're going to do a brief introduction to the MPLab X IDE environment and then look at setting up just a few of the hardware configuration bits. First thing we need to do is find MPLab X on our system and just start the program. When your window opens, it might look the same as mine. It might look a little different. In order that we can ensure that we all have the same look so that nobody gets behind because they don't have these panels, we're going to close all the panels and open fresh ones. So within each panel, there should be a title, a little tab with a title, and an X to the right. Simply click the X to the right of all of the panel names, and that will give us a nice, clean panel to work with. So now we have an empty interface. So come up to the menu bar at the top, click on the Windows tab, scroll down to a little over halfway, about 2/3 down, and you'll see a Reset Windows button. Click that. And then let's expand this. So here we have our basic Windows. We have a panel on the Start page, and then we also have an MPLab X Store page. If I click that button, once it's gotten a hold of the internet, it'll take us to MPLab or Microchip's page where we can buy additional features for our environment. We're not going to do that, so I'm going to close that tab. On the Start page, if I go to the right, I'll see links for Learn and Discover, my MPLab X IDE, and What's New. The What's New link is really if you've used MPLab X in the past and you're simply upgrading to this version. Well, how is it different? We're not interested in that. The My MPLab X IDE provides a way for you to log in to Microchip, and if you do log in, well, you'll be on your own homepage on their site, which gives you certain capabilities. We're not going to worry about that. The Learn and Discover is a link which takes you to various resources whereby you can research more features that MPLab X has. It has an abundance of very useful features. We'll get into some of them as the series progresses, but it's got way more features than we're ever going to look at. So there are a few other windows that we need, or panels. So come back to the Windows tab on the menu bar, click it, and go down one and click on Projects. We'll open a couple more windows later, but for now, this is what we need to start our project. I'm going to resize this window slightly because this is where my editor window will appear, and I really want more room. Next, I want to create a project. Well, I can create a project by clicking this Create New tab in the Start page, or I can click this button in the toolbar, or I can go to File and New Project. All of these choices will take me to the same window, so whichever you find most convenient. In selecting a new project, well, we want a Microchip embedded project. We want a standalone project, so then we'll click Next. In this window, we have to pick the family of devices. Ours is the last item on this first page without scrolling down. So you may have to scroll down. I don't. DSPIC 33, going to select that. The particular device we want is DSPIC 33FJ 64GP802. That's not the one that's showing. So that is in this list, and you have to scroll down till you find it. Now, from experience, I've learned that if I scroll to the bottom, move the cursor above the scroll bar, left click twice, my particular chip, the 802 will be visible. So I select that and then click Next. For hardware tools, we want to know what program we're going to be using. And for this series, we're going to be using the PicKit 3. It will program all of Microchip products, and it is the most cost-effective programmer they have. Sometimes it's a little quirky, but it works flawlessly the majority of the time. Click Next. Now we have to select a compiler since we're going to be programming in C, and since it is a 16-bit device. The only compiler I have installed is the 16-bit, so the XC16. Select it, click Next. Here we have to give it a project name, so I'm going to call mine MPLab Intro. Okay. It's already in the folder that I want. If you want it in a different folder, click Browse. Set as main project, yes. Use project location as the project folder. I also want that, so I'm going to click that button, and we're going to click Finish. So this makes a project for us. I'm going to open this window just a little bit so we can see some more things. Not that I need all this room, but I want you to be able to see it. So in our Projects tab, it's populated it with elements that we need. The only file that exists here, and we can see the files by clicking on this little plus sign to the left of each thing. We see there are no header files. There is one important file. It's a make file. There are no linker files, no source files, no libraries, and no loadables. Now the make file was created for us by MPLab IDE, and it's a file that is necessary to convert our code, our text code, into machine language that can be run. Down here in the dashboard, we have the name of our project, and within it we can see certain choices that we made. Our device, yes, it's the DSPIC33FJ64GP802. As we go down, we see that our compiler is the XC16. We can see how much memory it has. We can see that our debugging tool is the PicKit 3. It's not plugged in at this point, and then we have some various other pieces of information. I'm going to shrink that because I really don't need to see all of that. I don't need the start page because there's nothing more that I want to do here. But I do have to create a file, a source file. So I'm going to left click on source file simply to highlight it. Then I'm going to right click and new. Okay, I'm going to come over to the context menu. I could make a new directory, a new main XOC16.c file, a new header file, a text file, or some other type of file. I want a new main XC16 file. I'm going to click that. And here's where we can give it a name. We can accept the default. I'm just going to call mine main. I'm going to leave the extension as .c. And this is the default. It's already set. I'm not going to change anything else down here. Just going to click Finish. And it's actually going to create the main file for us. And it opens it up. So here we can see that my file is main.c. The author is David. It didn't take my last name, the date. It's included a header file, and it's given me a main file. Now, if you installed everything the way my previous video showed, with particular attention to the environment variables, this program's actually ready to compile. If we could load it and run it, we wouldn't see anything happen because it doesn't do anything. But if, on the other hand, we can't compile it, there will be an indication that we didn't set our environment variables the same way, and we have to do some additional work. So this button here says Build Main Project. We're going to click that. It should open a output window, which it did at the bottom, and then it's it's giving me a live update as to what is happening with the compilation. We see that it's complete. The successful is built. It took 5 seconds. There's various pieces of information in here. The address of the stack is at 800 hex. The maximum length of the stack is 4000 hex. Then we scroll up. We see that the data memory, there was no data memory use, so it's 0. Scroll up again, and we get to our program memory. Tells us where the program actually begins at address 200. Here is the length of the program. So this is the length of our program. Now there is additional material in our code that we don't see here because of the header file. So here in assembly, the code is divided into 2 sections, a .text section and a second .text section, and these are the addresses to which they're stored and the size of them, etc. So we have that information that compiles. This is great. Now, if yours didn't compile, then your environment variables may not be set up properly. So what you'll need to do is actually add a minimum of 2 more files to our project in the upper left-hand window. First, I'm going to select left-click once on linker files. I'm going to right-click, and this time I want to add an existing item. So left-click on that, and now we must navigate to where our compiler is installed on the computer. So mine is this PC. Going to select that. It's on drive C. Program files. It's going to be under microchip, and the compiler is the XC16. This is the version, and then there is a folder called support. I'm going to click on that. So I'm adding linker file. The particular device we're using is a DSPIC33F. Select that. Sometimes my double clicks don't work right. And because it's a linker file, it's going to be these GLD folders. So open that. Now I have to scroll until I find my device. So we'll click once. 64 GP. Here we are, P33F J64 GP802. And here we're going to leave the store path as relative, but I'm going to click the checkbox to copy the file into my project folder. So it actually copies it. I also want to bring in a header file, so I'm going to left click that to select it, then right click. I'm going to click on add an existing item, and this time I have to find the header file. So I'm still in the linker file, so I'm going to click up one level, and the .h are the header files for C, and again we have to scroll across until we find the particular one, the 802. So here we are, P33FJ64GP802. This is it. Select copy again, relative, select OK. Now I'm going to go back just for a moment to show you something. I'm not going to select anything this time. I simply want to show you. These are the C header files, one header file for each device. If I go up, this was our linker files. This is our C header files. If we were programming in assembly, then this inc folder would contain assembly header files. I just wanted to show you that. I'm going to click cancel to get out of there. Now, if you try to compile your project, it should compile. Whatever errors you were getting before, I'm going to trust that this has solved them. If it doesn't, send me a link with a detailed description as to the error, and I'll update the video accordingly. Okay, now that we've got our basic project, we need to set hardware configurations. We have two types of configuration we need to do with our chip. One is whenever we want to use a peripheral, be it general purpose I/O or the ADC or some other peripheral, we'll have to set software configuration bits so that the peripheral will work as desired. However, regardless of what peripheral we use, we still have to set hardware configuration bits. And that is something that it's done in code in C language, but our compiler can actually write the code for us. So that's what we're going to do rather than us learning how and learning all the details of the various fields, configuration fields. Come up to Window, the Windows tab in the menu bar, go down until you get to Pick Memory Views, and then go across until you get to Configuration Bits. Select that. It's going to open a window at the bottom with our configuration bits. I'm going to stretch that up a bit. Now, depending on the device we're using, there will be more or less number of bits. Essentially, we want to turn everything off that can be turned off. Things that can't be turned off, we're going to leave in virtually any state. So this is off, this says no, this says no, this says off, this says no, no, off, off. Good. Here we have something that says on. Well, actually we want to turn that off. Then we have none and off. This on we're going to come back to in a moment. I'm going to leave it for now. These here can't be turned off. They can only select various other functions, so we're going to leave them. Here we have something that's off. Here we have something that's on. We want to turn it off. It can't be changed or it can't be turned off. This is off. This can't be turned off, and this is off. So we've turned off everything that can be except this one thing. And this, actually, we now also want to turn it off. Not for the same reason as we turned everything else off. Everything else we wanted to disable. But this we want off because, actually, and all of that was wrong. So we wanted that off too. I made an error there. It's the one above that we turned off, but this one was for a reason other than we want to disable it. Here we turn it off so that the pin will actually function as a clock out function. So when we program even this basic configuration, we will be able to monitor a clock output on pin 10. That's why this one is off. One more change, and that's here, this FOS one, oscillator mode. We're going to click it, and we're going to go down and select the very last choice, the FRC choice. That's going to give us the high frequency internal oscillator at 7.37 megahertz. Okay, so again, turned off everything that can be turned off. Make sure that this OS2 pin function is off so that we have the OS2 pin has a clock output function. And then the FOS, we want to make sure it is set to FRC so that we're using the fast internal oscillator. Okay, now there's a link at the bottom or a button that says generate source code to output. We're going to click that button, and here it will actually write the code. So the code, for instance, the first line of code is this config this field name to this particular setting. The number pragma is a C compiler pre-compiler directive, if you will, which simply says, look, if a line similar to this appears again, only include it once. Well, I'm going to just left click anywhere in this field, and I'm going to hold down the control key and then press the A key to select all. Continuing to hold the control, I'm going to press the C key, which copies all of this into memory. I'm going to come back to my main C, And here above my include, okay, this has to be above the include, right after this should be the first thing in our code. I'm going to hold down the control key and hit V to paste everything. So this has pasted all of that code in. Scroll down, we see that it has given me a second include. This include here is part of this config section. It's really pointing to the same file as is the one that was before. So either of these, it doesn't matter, but one of these is certainly redundant. So I'm going to take and click highlight this and just hit delete to get rid of those. So this is my code. I'm going to save it and I'm going to compile it again. And this is ready to go. Now, one more thing I should do in main is, while this I could run, it's important that with microcontrollers that the CPU always have something to do. You don't ever want to let a program end, which really I'm doing here, and the compiler's looking after it. But what I should really do is something like this. So we're saying while one, do this, and we don't do anything in it. So just while this is forever true, and as long as it's true, don't do anything. So this is just going to loop back and forth and back and forth. We'll terminate that and we'll compile that again. Okay, so now I still didn't use any data memory. My stack hasn't changed. My program has gotten a little bigger. I don't recall how big it was before, but it isn't very big. So it's currently just 315 bytes. And now we're ready to actually program. So when programming, I may add a little video of this later, but you want to take your basic circuit and you want to power it up. So I've just plugged in the positive and going to plug in the ground. Going to power up my circuit. My LED comes on. Now, first thing you do is power up your circuit. Then take your DS pick. It's not plugged into the computer yet, and place it onto the programming header that's in your circuit. Then take and plug your DS pick USB cable into your computer. And we heard the chimes to let us know that it recognizes it. It hasn't updated over here, but we're going to assume it's fine. Now I'm going to come up to the right hand side or to the toolbar, and this time it says Run Main Project. Up at the top, we build main project, which compiles. We've done that. This builds it, putting in debug code. We don't want that. This will run the main project. We really don't want that. Make and program device main project. So this is what we want. It'll actually program it through the PICkit 3. If I click it, we see that it tells us, okay, how do you want to program it? It selected the PICkit 3 because that's what we said over here. We can see its serial number. Everything else is fine. We just say okay. And away it goes. It's compiling. Down here in the bottom of the status bar, we can see an indication that it is working. It still has to connect to our programmer. And the connection failed. Well, okay, if that happens, we're going to unplug the programmer, unplug the cable from the computer. Going to plug our programmer back into the circuit, plug the cable back into the computer, and we're going to click the button to make and program one more time. And this time it did connect. So, as I said earlier, sometimes the PICkit 3 is a little flaky. If it's flaky in the manner you just saw. So all I did was unplug the programmer from the chip, unplug the USB connection, plug the programmer back into the chip, and then re-plug it in. So currently it's still downloading. It's downloading some updates in firmware. This happens whenever there is an update from the MPLab microchip website. It downloads fresh stuff. So it has to update the programmer with the latest firmware before it updates or loads the program into the chip. So this doesn't happen every day, certainly not every time, but now it's ready to go. So now it's actually programming the chip, and it's done, finished, and verified. So our program should be successful. So now I'm going to plug in my scope lead into pin 10, and then just look at my scope, and I should see a waveform, and I do. So we're good to go. Our program was successful. So every time we write up code, we have to essentially repeat everything we've done here, with the exception of setting hardware bits as necessary and peripheral config bits as necessary. So thank you for watching.